So what I've done, I don't know if you've noticed it yet, but in the lab report assignment, I put two files. They are Excel spreadsheets. So if you're using Google Sheets, you can import an Excel spreadsheet. Um, when I do that, I usually then convert it to Google Sheets so that it's fully native Google Sheet. It's up to you. But I put two Excel spreadsheets so that you can go ahead and get your data, right? Because this is normally you would bring a thumb drive, or I would have a thumb drive, and you could borrow it, something like that, so that you can get this data. Because if you look at it, let me just show you, the spectrum is, a lot of numbers, right? No, you can't even see them; they're so small there. Scroll down. How many numbers is it? It's like 650 almost numbers. All right, so I don't expect you to write those down. But I would like you to have a representative spectrum in the final report, right? And then I also gave you the recorded test tube number and the absorbance. Now your wavelength, and in fact, I think maybe the Tuesday wavelength is not the correct one on the spreadsheet. Make sure that you report what we used, not what's on the spreadsheet. And this data is not your data. This is from years before when I did the experiment. But I'll go through a little bit of it just to show you what I'd like to see for the report. Well, the first thing is I would like to see a representative plot of the absorbance. Like I said, there's a lot of points, so you have to choose wisely how you want to plot this, because if you plot using symbols, then those symbols get really big. I'll show you what I mean. So if I do like the default scatter plot, I would get something like that with these big circles, all right? So instead, choose the line, right, so that it's nice and thin. Doesn't matter, since there's so many of them, there's very little difference between these two. Um, the, the one in the upper left where I am now, it gives you sort of smooth lines, so I usually don't use that because it's like faking the data. So just the real lines would be good, right? So you're going to need a graph kind of like this. You're going to label the axes, wavelength in nanometers, and absorbance, which doesn't have units. And it would be nice to not have 0 as the as your origin here for the graph, because it looks ugly. So what I would do is go ahead and change. If you double click on the x-axis, you'll get these options, and you can set the minimum value here to, well, 380 is where we started, so go ahead and make it 380. And then the maximum value, I think it goes to 900. Maximum would be 900. All right, so then you just see the spectrum. That's probably pretty fine. That's just fine with the numbers. I mean, you could, I don't know if I'd want to tweak it anymore. So that is the spectrum, representative spectrum. You could maybe, if you wanted to, put a little arrow where we're doing the maximum. So I did it at 462.8. You can draw a little arrow using Excel or Google Sheets if you want to. You don't have to. Just have one of these, give it a title, give it X and Y axes. So we're not going to do anything with that data other than just, I think it's always nice to represent it in the report to show that this is how we did our experiment. So let's go ahead and move on then to these data. Okay, so let me see, maybe I'll just move over and put them on a new sheet. Yeah, I'm going to add a new sheet and then copy this over to there so that I start over. There we go. Some new space. Okay, and let me go ahead and make that a little bit bigger. All right, so remember the first 5 were used for Beer's Law, and then the last 10 were used for the actual experiment. So let's go ahead and separate them out so that you can see things a little bit better. I'm going to shorten these just so that I can fit a little bit more on the on one page here. There we go. The other thing that you'll notice is that for this example here, these absorbances are actually just 3 digits, but the one I think that I uploaded, you get a lot more digits. If you want to make it 3, then you have to reduce the number of digits using the number of decimal points, make it look nicer. Not totally necessary unless you want it on, and you should, put it in, when you put it into Word, or whatever sheet, not sheets, docs, right? When you put make your table should have 3 significant figures. Good. What was I going to do? Oh, so now I need to figure out concentrations, because for the Beer's Law, I need to plot the concentration versus absorbance. So let me go back. I had, hang on a second. Let me pause this. I'm gonna move this. No, what did I do? I go to just me for a second, because I want to open a spreadsheet that I had last time so that I can see some of the numbers. I don't want you to see my spreadsheet, so I want you to do it. This one. Oops. Okay. And now I can show you. Okay, so now I've got the other data in front of me so that I can use it as my sort of cheat sheet to remember what the concentrations were. Ah, that's right. So we need to calculate concentrations of the iron from the very first concentration to the final concentration for the Beer's Law, right? Which is actually the initial iron concentration. That's the confusing part. So let me start that sentence over, maybe. Let me show you what I mean here by putting in. I'm going to put in some more rows so that I just have a little more work here, and I'll just put it here, I guess. So the table that I give you has the test tube number and something called dilute iron nitrate solution. And I have a blank there where you have to fill in the molarity. So what I did was I started with, let's see, concentrated iron solution that was 0.0025 molar, all right? And I diluted that, all right? So what did I do? I took milliliters of concentrated iron. It was 4, if you remember, right? It's a capital L, doesn't it? And then milliliters of dilute iron that I started with was 100. I put it into a 100 milliliter flask. So the concentration of the dilute iron I can calculate. This is going to be M1V1 to M2V2. So M1V1 is M2V2. So M2 is M1 times V1 over V2. This is always the way I think of it, just because it makes more sense to me, okay? So I'm multiplying my original molarity by a fraction, and that fraction is the original volume divided by the final volume. So that's 0.0025, and I'm going to do this in Excel here. 0.0025 times 4/100ths. And they're both in milliliters, so I don't have this there. It's going to be in molarity. 4/100ths is 1/25th. So I could actually do this in my head. It's going to be 0.0001 molar. All right, so there's your first answer. Well, let's do it in Excel. I'd say equals, what do I need? Concentration times volume divided by final volume. 0.0001 molar. Okay. Now that's actually not the final concentration though. The final concentration of iron, which is going to be the same as the concentration of iron thiocyanate. I'll leave off the it's 2+ and I need parentheses. I'm just doing it shorthanded here. Concentration of iron thiocyanate. Remember I said because I have so much thiocyanate, potassium thiocyanate in there, right? 1 molar, large volume, I convert all of the iron into iron thiocyanate. So the starting amount of the starting concentration of the iron nitrate is this 0.0001 molar, but I put that into a solution and dilute it, don't I? I put that 1 milliliter, 2 milliliters, 3 milliliters, 4 milliliters, and 5 milliliters into a final volume of 10 milliliters. So let me, final volume is 10 milliliters. Okay, and do is move this over here because I'll need that as my y-axis anyway. Yes. Milliliters of the dilute iron that I put in there, right? And that's 1, 2. I could have just used the test tube number, but when I do the actual values down here, I can't use the test tube number. I'm pretty sure that those are the right numbers. So that means that now I have to do another dilution. And again, this molarity is going to be my initial molarity times the ratio of volumes. And now my initial molarity is this 0.0001. The initial volume is, or the volume of that I put in there is this column, milliliters. And then the final volume is this 10, right? So that's what I'm going to put in this cell. I'd say it equals the concentration of the dilute iron, this one, and I'm going to hit F4. I don't know if you remember, F4 says always use that cell even when I move the reference. All right, so that's not going to change with my calculations. Times that volume, the milliliters of the dilute iron that I put in there. That does change, so I leave that alone. Divided by the final volume 10. So basically this first one is 1/10. I'm letting Excel do it for me though, because that way I can just do the other ones. Let Excel do the other ones by copying it down. I'm going to do F4 again and make that always the final volume. I don't want that to change. Okay. So there's my initial iron concentration, which ends up being the final concentration of thiocyanate in the Spear's Law one. And then I can drag that down and you see, yeah, sure enough, they come out what I expect, right? 0.00005, pretty small. 4 zeros, 5 for the last one. And these are the absorbances, all right? So now I've got something that I can plot as Spear's Law. So I'm going to select that and do scatter plot. Pretty nice. your data is a little bit noisier on both Tuesdays and Thursdays than when I got before when I did it. I would give it a better title than that. Here's law plot for lab 7. I don't know. It was 7, wasn't it? Okay. Give it titles for the axes. This is concentration in molarity of the iron thiocyanate. And the y-axis is absorbance. Now I'm gonna, let's see, let me move over because I know I'm gonna get a dialog box there. I'm gonna go ahead and add a trend line. So add trend line. I want it to be linear. Like it fits pretty nicely. Down here, there's something called, it's a little bit small on the screen, I know. It says set intercept. So set intercept, and the default is 0, which is what I want. I want you to do that so that it's forced to go through 0. If you noticed, it moved a little bit. All right, because that low concentration one is a little bit high. Now, there's a couple ways to deal with that, but just to make it simple, I want you to set intercept equal to 0 so that if I display the equation, you'll see it's just something times x. Okay? You don't have to put any statistics on it. So now, that gives me the slope, which is the k value, right? Now I could write that in, or I could go ahead and get the value. So let me just show you really quick. The k value is going to be the slope of that line, but you can't use the slope function because the slope will fit it with an intercept, right? So I want it not to have an intercept. I need to use a different function. It's called linest. Linest, linear estimation, all right? And it takes arguments y, x, and then I can tell it false, which means I don't want an intercept, okay? So that's what I'm going to put in. Equals linest absorbances, concentrations, and then it says false, and no, you can't read it. False, b is set equal to 0. True, b is calculated normally. That means the intercept. So I want false. It doesn't have to be capitalized. And then I'm going to end parentheses. There's one other argument that you could put in, but it's optional. Talk about that in chemistry. Okay, so there we go. Now I have the number that I can use for my calculations. And if I went back and I thought maybe I didn't calculate this right, so, oh, wait, I used 5 milliliters, right? Then it updates. All right, that's kind of nice. So that's my K value that I can use to figure out concentrations of iron thiocyanate for the second part. So let's go ahead and do that. Let me move this over so that's underneath where it should be here, right? And now I need to find concentration of iron and the concentration of thiocyanate that I started with, which are also from dilutions. So this is iron, and this is going to be my SEN minus that I start with, right, before it goes to equilibrium. So this is how I made it. All right, so maybe before I even do that, I should move these over. Some more columns there. Milliliters of iron, milliliters of thiocyanate. Okay. I don't have it with me, but I seem to remember it's 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. Wait, do I have it over me? I do. Hey, all right. 1, 1.5. Oops. 2, 2.5, 3. That's it, right? Yes, and then copy that. Control C, Control V. Okay. So now I need to know that what these initial concentrations are, right? So the stock concentrations, they were 0.00025 molar and 0.00025, right? No, just two zeros. What's that? Okay. And then my final, I put that, insert that, final volume, 7 milliliters. All right, because I always dilute with nitric acid to get a total of 7 milliliters. So what's the initial concentration of iron 3? It's going to be the amount, the concentration of iron. So this is my iron and this is my SCN, by the way, they're the same number, right? Concentration of iron times the ratio of the volumes, 1 to 7. So equals stock concentration times 1 divided by 7. All right, and this one, very similar. In fact, I bet, let's just pull this over. It's going to be this over. You can take a look at the video later on if you want to see what I just did there. Doesn't matter really because the concentration of thiocyanate was the same as the iron. Those are ready to go. There we go. There's all the concentrations that you need for the iron and thiocyanate. Now, how do I get the concentration of the iron thiocyanate? Plus 2. Whoops. And I'm just about out of time. Let me go ahead and show that to you really quick. It's from the absorbance. It's going to equal the absorbance divided by my K value. Don't want the K value to change when I drag that down. Gotta drag it down. The iron concentration at equilibrium is equal to its starting concentration minus the amount that was made into thiocyanate. Same with the SCN concentration at equilibrium. It's equal to its starting concentration minus what I converted into thiocyanate. All right, and what's the K value? K value is products divided by iron reactants times each other. Everything is a 1 coefficient, so there's, I got 568. Write that down. And you'll notice right away, I wanted to make sure I got to this last part because this number, for some reason, the first test tube is always too high. You'll notice it when you do yours as well. These values, not bad. They're all around 100. A couple of them are, I mean, that's 200, a little bit higher. Might be able to throw that out. But I would, instead of taking the average of everything, I'd get 165, and these can be reported to no digits after the decimal. Let's see. All right, 166. But what I would do is just take, I would report that, but then I would also report what it would be if I don't include that one. You notice it goes all the way down to 1. That's a better answer. I would report both of them and explain why you got rid of that first one, which is just because it's way big. And it always happens. It happened this year. It happened this year when I did it this week. I don't know why. So that's it in a nutshell, and a little bit over time. So hopefully you can replicate this and get similar answers with this year's data. These numbers are pretty close to yours. They're not exactly, but you will get numbers that are on this order of magnitude. Okay, so that's it. It's spring break time, or well, as soon as we finish classes. But you guys go. If you're still around and want to do the exit poll really quick, great. Yeah. All right. So have a great spring break, and I will see you a week from Monday.